1 second.
Yeah.
Oh, is Larry coming?
How's everyone doing? Did you guys eat? Did you guys eat your chicken tikka masala?
Sit anywhere?
I think so.
Okay.
All right. I know this is a little offbeat. What we are going to do is we are going to get 3 CEOs
That's the hard part.
to explain Bitcoin and blockchain to
Yeah, good point.
a kid and to a grandmother.
Yeah, this is really good.
All right.
Really
If you
rough.
guys are sitting far off, I recommend you guys to come up
Sorry,
front
do you wanna
because you may
change?
want to tape this. Right? This might be easier
Here, it's
to
pretty
explain
bad,
it to
too.
your family when you go back.
It's like
All right.
blocking.
We have Kanish. Kanish, say hello to everyone.
Hi.
We have Mahbood. Mahbood, that was a great presentation.
Thank you, thank you.
And do you have a mic?
Shamim?
And Justin
Hey.
and Colin.
Hi there, Colin Research.
So, are you guys ready, by the way?
Let's do it.
All right. Colin, why don't you explain Bitcoin to Kanish?
Kanish, Bitcoin is a way to send money over the internet. So 2 people can connect through a network of computers that all have a record of how much money you have. So if it says that you have $5 and then you choose to send money to somebody else, it will take it from your computer or your account, and then it will automatically put it into the other person's account with really nobody in the middle. You don't need to go to a bank or to involve anybody else. It all happens automatically. And there are thousands of copies of this information, so you don't need to trust anybody. It will check on all these different computers to make sure that the number is right. So it's very secure.
What do you think, Kanish?
It's not that bad.
Not that bad. All right. Justin, do you want to take a shot?
I'll give it a try. So, do you remember Halloween from last year? Did you go trick-or-treating?
Yes.
Did you get a big bag of candy?
Yes.
When you got the big bag of candy, were you able to keep the big bag of candy in your room? Or did your
No.
mom and dad keep it?
No.
Your mom and dad kept the big bag of candy? Would you have rather that you kept the big bag of candy? And that you were the only person that could control when candy came out of the bag and who
Wow.
that
Yes.
candy went to?
Yes.
That's what Bitcoin is, except for money.
Nice. Kaniki, did you like that?
Bitcoin lets
Did
you
understand
keep your
what
candy.
Bitcoin is?
Yeah.
Yeah. Okay. How about Mahbood? Do you want to give
Very
it a shot?
interesting analogy. Well, the way my explanation to like younger people is usually more for blockchain. I just think an interesting way to think of it is with the internet, the thing that the internet did was it let you send something to someone else automatically, like you can send email, but then when you send email, you keep a copy for yourself too. So the internet lets you send something automatically, like instantly, but it's impossible to send it without being able to keep a copy for yourself. So the blockchain lets you send something electronically, but it's impossible for you to keep a copy for yourself. So the person knows there was only one of it, and you sent it to them, and you didn't keep a copy for yourself.
Thanks, Mahbood. What do you think, Kaniki?
It's pretty simple.
It's pretty simple. All right. Awesome. Why don't we try blockchain next? Colin, do you want to help explain blockchain? And by the way, you guys can have a conversation, so it's not just one way.
Let me sit back. a little
Yes,
bit
I
so
think
that
we
you
should
guys
make
can
it a
look
little
at each
curve,
other.
yes.
No, you guys should be able to
Yeah.
see each other.
Okay.
So you look pretty savvy. You're familiar with computers and the internet?
A little bit, yes.
A little bit. So blockchain is basically a way to store information across a whole bunch of computers that all have the same copy of the same information. And so you can look to see if that information has been changed. And because it's the same across 1,000 different computers, it's very difficult for somebody to change it after the fact. So if I say something to you, it's basically impossible for me to change it afterwards. It works best for money. So if you think about a checkbook, and when you write a check, and then you have your little ledger afterwards where you write, oh, I just took $10 out of this account, it would be like if people had their checkbooks connected automatically, and when you wrote that $10 came off, it would automatically update thousands of different checkbooks, including the person that you sent it to, and on theirs it would say, oh, I have $10 more, because you've sent it to them.
But what is the advantage of having so many copies of the same thing across the internet or whatever?
It's a really good question. Well, if you only had one copy, or if you had a couple of copies, somebody could go and change those 2 copies and take the money from yours and then put it onto their own. But if there's thousands and thousands of copies, it becomes very secure because they would have to change them all, and it's almost impossible. So when it gets changed, you know that it's permanent and it's true, basically.
And these sources or network systems, they are not connected to each other?
They are all connected through basically a peer-to-peer network. So there's nobody really in the middle. There isn't a bank. It's just a series of servers that talk to each other.
And it's run by a human person sitting there, or what?
No, it's run by software, and it's basically open source. So anybody can look at it to make sure that it's not lying, that it's all true. And so as long as everybody's on the same system, it will have the same information.
But if there are so many of these out there and several of them crash at the same time, won't my data get lost, or?
That's a good point, and that's why you want so many copies, because it would take a lot of them to fail for it to be completely lost.
Okay, and this is, you're explaining about blockchain.
Blockchain, yeah.
I had another question, and this is, I had heard recently that the United Nations is using the blockchain technology to, they're experimenting to pursue some of their projects. And I wanted to understand how that would help them. One area they're doing it is in climate change. Another is for humanitarian aid. And the other is for these displaced refugees and their identities, displaced people and refugees and their identities. So how does the blockchain, how would the blockchain work for these situations?
Yeah, so the nice thing about blockchain information is that anybody can view it. So they have something called a blockchain explorer, which enables you to view the information. So if it was something that needed to be viewed by a whole bunch of different people, they can basically ensure that they're all looking at the same information. So it's public, and because of that, it's transparent.
Okay.
And because it can't be changed after the fact, you can't doctor the information. So if there was certain climate data, for instance, and it was put onto a blockchain, then once it's out there, it can't be falsified after the fact. Whereas if it was on somebody's computer, they could alter it to suit their purposes. And for identity, it's very secure and, again, kind of pure and true. So you don't want somebody to be able to go in and alter your identity or steal your identity. And so each identity would have a private key that only one person would have access to. And as long as you control that key, nobody else can make changes without your approval. And so it's just a better way to store information.
Justin, do you want to take a shot?
That a lot.
Sure. Am I starting over again, or am I jumping in, or how am I doing this one here?
Just give it a shot. Like, just.
Yeah. Okay. So if I was going to describe a blockchain to you, what I would start with is the idea of a shared document, like a Google Doc. Have you ever used like a Google Doc or a Google spreadsheet before, where multiple people can go in and edit the document?
No, I don't use that, but I know of it.
You understand
Yes,
the concept
yes.
of what we're doing there, right? That's great. And those are very useful tools, but in order to use a tool like that, let's say that I wanted to run my business on Google Spreadsheets, right? I have to trust Google.
Yes.
Because Google can go in there and change the numbers that are in the spreadsheet. They could delete it. They could lose it. They could do other things like that. And there's a lot of things in the world today where there's people that, or institutions that get a lot of power out of being trusted to do things for us. What blockchain has done is, using software, they've been able to move that trust from an institution, from a company or an individual, and move it into the network itself. So instead of Google controlling how the file gets changed, the software that all of us are running controls how it gets changed. And if someone tries to go back and change history, it won't allow them to do that. So that there's a consistency. And then finally, different than a shared document, instead of going in and changing the document, all you're able to do is append new things to the bottom of it. And so it's like a running log that can go on forever. And so when you talked about the UN use case around climate change, and I think he gave a great example of it, you know, there's been countries that have been accused of tampering with their sensor data around climate readings, right? Well, if you had the sensors themselves are writing that data directly to a blockchain or just to a log secured by blockchain, there's no opportunity for a third party to either write fake records into that blockchain, because they wouldn't be able to impersonate the device, and they wouldn't be able to change those records after the fact. And so what it gives the UN, for example, there is a much more trustable record of what's actually occurred, and apparent immediate evidence if someone attempted to try to tamper with that log.
But then the issue always remains that who is the first entity who is entering that data, right? Whether that first entry is correct or not.
That's absolutely true. And one of the things that can be valuable about the way that blockchain works, because it operates on cryptography, where a sensor would, say, have a private key embedded in it that's used to sign all of its data. Well, what that means is I can't impersonate that sensor. And if that sensor starts giving bad data, we can exclude it from the network because it's a known actor. Where today on most networks, it's very difficult to know who inserted or who changed a piece of data in the network. With this, you can track the data back to its original source to make it easier to carve those bad actors out of the network.
Thank you, Justin. Mabo, do you want to try it in 30 seconds?
Well, I had a question. You said, why are there so many of them? Could you clarify what you meant?
No, I mean, because it was explained as there are many copies of the same data available in all these independent computer systems, as I understood it.
Oh, okay, I thought you meant the different, why are there so many different tokens?
Oh, no. Because,
Okay.
I mean, I did understand it correctly, right? That there are several copies.
Absolutely.
Okay, I know we are out of time, so I'm going to ask the audience for the Bitcoin, whose explanation did you guys like the most?
Hey.
Halloween, so that's Justin. Justin, raise your hand.
Candy wins.
Justin is going to give you free software, anything you want, for the next 2 months to get to his booth.
My dad ran a chocolate factory when I was growing up.
For the blockchain, what do you guys think? All right, thank you. Appreciate it. Thank you, Colin. Thank you, Justin.
Thanks,
Thank you, Mahbod.
Thanks.
Thank you, Kanish. Thank you, ma'am.
Good job, man.
Thank you for the explanation.
Thank you.
Thank you.